Good morning, children. Let me take the lesson thermal physics. So, thermo means what? Heat. So, studying about heat, then what are the quantities of heat, what are the properties of it, everything we have to see very detailed in this lesson, thermal physics. It's in page number 32. So, first we have to say from where we are getting the heat. So, which is the primary source of heat? Sun is the primary source of heat. From all the every living organism, they need the heat in a certain quantity that can be taken from sun only. Sun is the main source of heat energy. Okay. So everybody needs a particular temperature for our survival. Even our normal body temperature is what? 98.6. So this is 98.4. Sorry, 98.4. So this is because we need the temperature to maintain our body. The same like every object, every living thing, they need the temperature, that is heat. The particular temperature, the particular amount of heat we need to maintain our duties is known as what? Studying about all those things is known as thermal physics. So everybody needs the thing for the survival. So we have to say what is temperature. Sun is the main source of heat. So sun is otherwise what I said, it is heat. What is the thing? What do you mean by temperature? Temperature, it says whether the object is hot or cold. So the measurement of hotness or coldness is known as what? Temperature. The correct definition we want to say means it is the degree of hotness of a body. The degree of temperature is the degree of hotness of the body. Okay. So further we can see the SI unit. For everything we are using the unit now. SI unit of temperature is Kelvin. Kelvin is otherwise known as absolute zero. So it is also known as SI unit is Kelvin. There are three kinds of temperature scales. They are Celsius, Fahrenheit and Kelvin. What are the three kinds? Three kinds of temperature are Kelvin, Celsius, and Fahrenheit. Okay, there are three kinds of temperature, Kelvin, Celsius and Fahrenheit. So, temperature, that is scalar quantity. It is vector quantity. There are two kinds of quantity, vector and scalar. Temperature is scalar quantity because it has direction as well as magnitude. Okay, so what are the things we come across? Temperature is required by all the living organisms for their survival. So, sun is the main source of temperature. The SI unit of temperature is Kelvin. Further, there are three kinds of temperature, that is Kelvin, Celsius and Fahrenheit scales. Okay, then this is scalar quantity. It has direction as well as magnitude. Clear? Magnitude. So the first thing we have to see these 3 points and important points, and as usual you have to underline, no, like that you have to underline. Then this Kelvin scale is otherwise known as absolute scale. Kelvin scale is otherwise known as what I said, absolute. Absolute scale, absolute zero. This is nothing else. This is minus 273. This unit is, this scale is minus 273 degrees. minus 273. Absolute scale is, what is the measurement of absolute scale means minus 273 K. Then even easily we can convert Celsius into Fahrenheit, Fahrenheit into Celsius. So how to find out Celsius and Kelvin means, Celsius scale we can find out that is K for what? Kelvin. Kelvin is equal to Celsius plus 273. Suppose the temperature is given in the Celsius, we want to find out how much Kelvin it is. So we have to add Celsius, that is the temperature what is given to you. You have to add along with the 273. So this is the formula to find out. We can convert one degree of hotness to the other degree of hotness. That is in case you want to convert the Kelvin scale, the Celsius scale is given to you. What you have to do? Celsius scale you have to take. For example, Celsius is 10. Then Kelvin is absolute 0 is 273. Altogether 283. 283 Celsius. Like that you can do. Clear? Kelvin scale you can find out like this. Suppose in case we want to find out Fahrenheit. This is Celsius. Fahrenheit we want to find out means, that is F Fahrenheit plus 460 into 5 by 9. By using the formula, by using these two formulas, we can convert one temperature into another. Suppose we want to find out from the Celsius scale is given to you, you have to change into Kelvin. What you have to do? Celsius plus 273. What is 273? That is absolute 0. Then centigrade is given already to you in the question. Clear, children? And Fahrenheit, if you want to convert the Fahrenheit into Kelvin, that is the degree. Fahrenheit degree is given in the question. You have to take down. You have to add with 460. And first you have to clear the bracket. That is Fahrenheit and 460. Both you have to add and you have to divide by 5 by 9. We can get the answer. Clear? So what are the things? How to change? What are the 3 degrees of hotness we have seen? Then how to convert Celsius and Fahrenheit into Kelvin. This is it clear now. Then thermal equilibrium. Equilibrium means what? Equal. That is plus is equal to minus. Plus 5 minus 5 minus 5. Equilibrium. That is both are equal. Okay. Yeah. So like that we are finding out equilibrium. That is known as heat. It is flow of energy. It is the form of energy, I say. It flows from one area to other area. From the higher level to lower level. So this flow is known as thermal equilibrium. Suppose if 2 bodies are given to you, the 2 bodies, the heat is compensated each other. That is from A, the heat energy flows to B. There are 2 objects, you consider 2 objects. One is A, other one is B. From the A, the hotness flows to the B. Both are equally compensated. That is known as what? Thermal equilibrium. Underline this point. What is thermal equilibrium? 2 or more physical systems of bodies. So systems you can write within bracket. 2 or more physical systems or bodies are said to be in thermal equilibrium if there is no net flow. That means what? There is no flow between them because both the flows are already compensated. It's known as thermal equilibrium. Heat energy always flows from one body to another body. That is due to the temperature differences between the 2 bodies. One is A, it has high temperature, other one is B, that is low temperature. From the A, the temperature, the heat flows from the A to B and both will be at certain level, both will be in the equal degree of hotness. That is known as what? Equilibrium. In short, we can say, for example, you can say that is 2 bodies are said to be because both are equal. That is known as what? Thermal equilibrium. For example, hot water you are taking for bath. So while you are taking the hot water from the heater, from the stove, whatever it may be, it is very hot. After you are pouring the hot water into cold water, from the hot water, the degree that the hotness goes to the cold water. Cold water receives the hotness and both are compensated together. Such a thing is known as what? Equilibrium. Okay. So this energy, doing the transaction, that is heat flows from lower level to the higher level, that is known as what? Both are compensated. Thermal equilibrium. they transfer some energy. That energy is known as thermal energy. So thermal energy it's a form of energy which is transferred between the two bodies due to the difference in the temperature. Now we have seen thermal equilibrium and then what? Thermal energy. What are the points we come across? Thermal equilibrium, I said both A and B are compensated. Thermal energy. What is thermal energy? You underline from page number 33, the second paragraph opposite side, fourth line. The thermal energy is the form of energy which is transferred between any two bodies. That is any two bodies. It doesn't mean that particular body, any two bodies due to the difference in the temperature. Clear? I said already it is a scalar quantity. So thermal energy, the unit of thermal energy is joule. Then what are the characteristics of the heat transfer? That is heat transfer from A to B, I said, to become equilibrium. So what are the characteristics? Heat always flows from a system of higher temperature to a system of lower temperature. First point I said, heat. What are the properties of heat? That is, they flow from higher to lower. First point. Properties. What are the properties? The transfer from higher form of energy to lower form of energy. First. Next one. The mass of system is not altered when it's heated or cooled. So, the system, that is, the system is not altered. Whatever the system may be, system means what? The process will not be altered. Altered means not changed. And the third one, for any change of heat, the heat gained by the cold system is equal to heat lost by the hot system. That is, heat gained, heat lost. So, this is heat gained is equal to heat lost. These are the three characteristics of the heat. That is, the heat transfer from higher level to lower level. There is no alteration. That is, heat gained is equal to heat lost. Clear? Now we have to see what are the other units of energy. What are the other units of energy? What are the other units? Units means what I said? Measurement. One is calorie, other one is kilocalorie. Both are almost same only. If it is 1 gram means calorie. If it is mentioned for the 1 kilo, that is kilocalorie. So we'll see in the page number 34. The SI unit of energy is joule. There are some other commonly used units. One is calorie, other one is kilocalorie. What is calorie? 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. That is what is it is the heat energy required. That is, calorie is the heat energy required. Required for what? To raise the temperature of 1 gram of water. That is, water temperature is the normal temperature. For example, 4 degrees Celsius. 4 lenda 5 So that is, the temperature, raise the temperature of water, 1 gram of water to 1 degree is known as calorie. 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. This is calorie. Kilocalorie also the same only. In the place of 1 gram, we have to write 1 kilogram. So, kilocalorie, 1 kilocalorie is defined as the amount of heat energy required to raise the temperature of 1 kilogram of water through 1 degree Celsius. Okay, clear? So, units, first I said already. First one is Kelvin, that is the temperature scales, that is temperature, that is Kelvin, Fahrenheit and then Celsius. Then heat we are measuring as joule, calorie, kilocalorie. Clear? Then what are the effects of the heat energy? Suppose you are eating an object. Maybe sphere. One sphere we are eating. Due to the heat, it may change the shape. So dimension, shape, both are same only. So because of the heat, they may change the dimension. The object, whatever the object you have taken, if you are going on eating the object, they will change the shape. They will change the dimension. So, what are the thing? What are the effects of the temperature, heat energy? What are the effects? So, after heating the object, what are the consequences? How the object will be changed? Temperature of the substances rise. Before that, there is no hotness in the object because we are supplying the heat to that. The heat passes through the object and the object becomes what? Very hot. That is, temperature of the substance rises. Next one, the substance may change its state from solid to liquid or liquid to gas. Suppose if you are heating the solid, it may convert into liquid, or suppose if you are heating the liquid, it may convert into gas. The substance will expand when heated. What are the three effects? One is the heat substances raise, temperature of the substance raise. Other one, it changes is the state of unit thing form. That is, say the solid may change into liquid, liquid may change into gas. The substance will expand on heating the object. So, these are the three effects of the heat. Then what are the expansion? We have seen now. Now we have to see what are the expansion of heat. What are the three kinds? Because we know well, objects are in three states, that is solid, liquid and gas. So, what are the effects of the heat while heating a solid object, liquid object and gaseous object? We have to see now. Now we have to see expansion of the object. What are the three states of the object? I said solid, liquid and gas. First we will see solid. When the heat energy is supplied to a body, there can be an increase in the dimension. Dimension means what? Shape of the object. For example, in the solid alone, there are three kinds of expansion. One is linear expansion. This is for solid alone. Linear expansion. Superficial expansion. And the next one is cubical expansion. So, the three expansion, this is nothing else. So, object that's a regular shape it has. Suppose the expansion in the length, that is in the length, it is known as what? Linear expansion. That is solid object, expand in the lengthwise, that is known as linear object. So, expand in a expands, this is length I say. If it is expand in the area, that is area, what is area, So, if it is expand in the case of area, this is known as superficial. If it expands in the volume, that is gases, this is known as what? Cubical. So, expansion of solid alone in three states: linear, superficial and cubical. Linear means I said the expansion occurs in the lengthwise. Superficial expansion occurs in the area, that is the space occupied by the object. And cubical, it expands in the form of volume. So, this increase in the volume. These are the states of the expansion of object. Now, further we have to see expansion of liquid and gases. So far what I have taken is clear. I hope so. Okay. First one we have seen what is sun. Sun is the main source of heat. Then what are the three kinds of temperature I said? That is Kelvin, Celsius and Fahrenheit. How we can convert one form to other form, that we have seen already. What are the effects of the heat? Then what are the properties of the heat? Expansion due to the objects, that is solid, liquid and gases. Solid alone, three kinds of expansion: linear, superficial and cubical. So, liquid and gases we will continue in other class. Thank you, children.